Hello everyone and welcome to today's session. The topic for today's webinar is Deep Learning and Computer Vision Initiating a Huge Transformation in Today's World. A recorded version of this webinar will be available on Navcara YouTube channel. We would love to hear from you at the end of this webinar. If you have any questions, please write on the chat window. This webinar is hosted by Navcara Consulting. I am Vincy Thomas and I will be the speaker for this webinar. Kindly go through the company confidentiality. Navcara is a leading global consulting company that is specialized in digital transformation. We serve clients across spectrums of industry, including healthcare, public sector, federal, and commercial. From this webinar, you will be understanding the following. What is computer vision, deep learning, convolution neural network, application in different domains, and finally a case study based on phase and object detection using Tensorflow and OpenCV. What is computer vision? Computer vision is a field of study that develops techniques to help computer to see and understand the content from digital images like photographs and videos. It is a multidisciplinary field which makes use of different machine learning and deep learning techniques for attempting to reproduce the capacity of human vision. Computer vision basically extracts information from digital images. This information can be anything from 3D models, camera position, object detection, to grouping and searching image contents. Deep learning. Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence or AI. Artificial intelligence is a technique which enables a machine to mimic human behavior. Machine learning is basically a technique to achieve AI through algorithms trained on some data. Deep learning is inspired by structure of human brain. This structure is called artificial neural networks in terms of deep learning. This artificial neural networks consist of many layers where each layer can perform complex operations like feature extraction, segmentation, representation, and abstraction that make some sense out of image, sound, and text. Furthermore, deep learning is preferably in situations where there is a large amount of data, lack of domain understanding, and problems where complexity of data is high, such as image speech recognition. Convolution neural network is a deep learning based neural network that takes two-dimensional array as input and then shares parameters for processing data within a multi-layered network. Convolution neural network is commonly used to detect and classify objects within an image. The image shown here is a convolution neural network that will identify object from the image fed. Imagine this is an image of a dog and I want to confirm whether it is really a dog or not. So firstly, I will pass the image as input to the multi-layered neural network. The input layer will take the pixels of the image in the form of 2D array. The hidden layer carries out feature extraction, performing different calculations and manipulations. Hidden layer has multiple convolution and pooling layer for extracting feature from the image. And at the end, a fully connected layer identifies the object from the image. Deep learning is used in different domains like image detection. Given an input image, features are extracted from the images and classified the image. Then one or more boundary boxes are produced with the class labels attached to each boundary box. These algorithms are capable enough to deal with the multi-class classification. Face recognition. Given a person's image as input, model can recognize the person's face and display appropriate label for it. Pixel restoration. It is a process of recovering high-resolution image from a given low resolution image. Image may have low resolution because of some degradation, but we can recover it using deep learning techniques. Automated cars. Automated cars undoubtedly is an amazing technology developed using deep neural networks, which can detect objects around the car, identify traffic, locate distance between the vehicle, and so. Intelligent transportation system. Deep learning has initiated improvement in traffic management and traffic planning, increasing safety and security in transit routes. Also, the cost of maintenance has reduced. Virtual assistant. Popular virtual assistants like Alexa and Siri are developed using deep learning technique in their backend. Automated handwriting generation. This application of deep learning involves generation of new set of handwriting for a given corpus of word or phrase. The handwriting is essentially provided as a sequence of coordinates used by a pen when the samples were created. The relationship between pen's movement and letter is learned and a new example is generated. So now let's start with the case study, face and object detection using OpenCV and Tensorflow. Face detection. For face detection, the tool I'm using is Google Colab, and OpenCV is a Python library designed to solve complex computer vision problems. DLib. It is the open source C++ library implementing a variety of ML and deep learning algorithms. Face recognition library. It is used for recognizing and manipulating faces, and it is built on DLib state of art with deep learning in its backend, and it requires GPU. Then I created two directories, known and unknown faces. Known faces directory contains images with label, and unknown faces directory contains images without any label. Workflow. For all known faces in the input image, the model generates some encoding. Then it compares it with the encoding of the unknown faces, and then it displays the result for it. For object detection, I have used TensorFlow Object Detection API, which is offered by TensorFlow for solving complex deep learning problems. TensorFlow, as its name suggests, consists of two components, tensors and data flow graphs. Tensors are multidimensional arrays in which the data is stored. Then it is fed into the neural network, and then we get the output. Similarly, data flow graph maps the flow of operation where each node in the graph represents the mathematical operation and the edge represents the data consumed. TensorFlow Object Detection API is a framework which has pre-trained models. This set of models is referred to as Model Zoo. It allows us to easily build, train, and deploy object detection models. I have used a model which is trained on COCO dataset, that is Common Object in Context dataset. COCO dataset contains around 300k images, out of which 90 are commonly found objects like person, car, chair, table, etc. The tool which I used here is Google Colab. Libraries which I use for object detection are TensorFlow, Matplotlib, Python library for plotting images. Below, it is a library which is freely available that supports opening, manipulating, and saving many different images. TF-Slim provides common abstractions which enables user to define models quickly and concisely. Protobuf, it is used for translating image file into a format that can be stored in a file. It is also used in developing programs to communicate with each other, and it emphasizes the simplicity and performance of the program. Python gives a C-like performance with code that is written mostly in Python with additional C-inspired syntax. Pandas is a data analysis library. Then coming to the model, I used for object detection, that is faster RCN inception model, because it gave me a better accuracy while detecting object compared to SSD mobile net. Finally, I have integrated face detection and object detection using a Flask web app. Now I will show the demo of my project. This is my face and object detection web app. Here I can upload an image to detect objects. Yeah, so here the object is getting detected and it is giving me 99% accuracy. Now I will upload video. So here in this video, the objects are getting detected, person and car are getting detected. Now for the face detection part, I will upload an unlabeled image here. The model is giving me the output saying this is Barack Obama. For concluding this session, deep learning and computer vision is capable of automating several complex tasks, providing a lot of benefits like cost reduction, simple and faster processing, better deliverables, etc. If you have any doubts related to this webinar, kindly mail us at info@navcara.com. Here I have completed my presentation. I hope you understood the basic concepts. Thank you for being such a wonderful audience.